Okay, hey everyone. Good morning, good morning. How are we all going? Okay, everyone's stressed out about the specification. Can you all hear me okay? I feel super quiet. I'm too quiet. Is that better? No, I think it was me. How's that? Yeah, so I'll speak up. Okay, cool. With the project, I know you all might be stressed about it, but really, it's nastier than it looks. It looks nastier than it is. It really isn't so bad once you get your head around it. I mean, a lot of it is just information about how we're assessing it and all of that stuff. And then we just provide the specification. And throughout these lecture series that are going to be coming up, we'll talk to you and teach you more how to consume that specification and create what you need to create. Yeah, Freudian slip. It's nasty that it looks. No. So yeah, don't worry about it. Let me just close this. You will get there, and your tutors are there for help. All the tutorial content is there to help. It doesn't get worse. Well, it gets worse in iteration 2, I guess, but not so bad. I mean, last term, every single group got through all the iterations, so you're completely fine. Cool. Okay, why don't I do that? Let me give you guys links back to the project videos because those are really important. I'm not really going to talk specifically about the project videos right now. So let me go to YouTube. Videos. Where are they? Okay, hold on. I mean, so if you go to your project repo, go to the project backend, in the README, there are links to 2 videos. I'm going to post the links for you now. Don't watch them now, please. Watch them after the lectures. Yep, that's right, in the GitLab project. They didn't lose their sanity. Everyone survived. Okay, we've got a lot of stuff to get through in this lecture. First of all, I hope everyone's been doing okay. I hope everyone's okay with the whole train situation. And just like Murphy's Law, 3 minutes after I posted the announcement last night, ABC News on my phone lit up and said that the trains would be running. So that was a waste of an announcement. But the other thing I announced last night is that I've given everyone a 1-week extension on the Lab 1 activities just because of some of the GitLab related issues and all of that stuff. So I hope that helps those of you who need that 1-week extension. But please don't utilize the whole week now on week 1 labs, right? You still need to have your week 2 labs in on time. So, but hopefully that helps out a little bit. Okay. Let's see here. Got some cool things in store for you guys today. Let me just hide all my windows. Alrighty. If you can't clone via SSH, it's most likely a you problem now. The system is all fixed. So I would recommend going to a help session if you've got any technical issues. Alrighty, so for the first chunk of this lecture, we're going to talk a bit more about Git, and specifically we're going to talk more about how you use Git with other people, right? So this is a really important part of Git. It's one of the reasons why it was designed. without working with other people, we wouldn't really need something like Git other than like a backup solution, right? So how is this going to help you in your project? Well, in your project, there's 4 or 5 of you working together, and part of the assessment of the project, and we talk about this in the specification and in the videos as well. Part of the project is using the Git system correctly and collaboratively. So in this lecture, we're directly going to support you in doing that. Okay. So we've spoken last week high level what Git is for solo usage. In this lecture, we're going to talk specifically about some of the collaborative features. So branching, merging, and merge requests. They're the 3 things we're going to focus about. Really, for the project, these are as advanced you need to get in terms of Git concepts. So branching, merging, and merge requests. Most of what we're going to do today is going to be done on a demonstration that I'll do in my environment. But there is a written guide to, if this is another way that you want to consume this content, Atlassian has a great Git guide here. You can go through and get started on their tutorial. We're not going to do that today. I'm going to do my own thing, but you have that sort of backup source there. Now, I've said this when I came through to see some of you in the tutorials this week. Hello again if I saw you. Git will seem very complicated and opaque and complex the first time you're getting used to it. It really takes 6 months to a year, depending on how often you're working with it, to get comfortable with Git. So it's completely normal to feel like this, I promise. I was the exact same way. And then things start to click. And hopefully what I teach you today helps you start to click, and you will understand sort of how it works and what we're doing. So last week I spoke about Git being a sequence of commits, right? And those commits are a snapshot of a project. And the way we spoke about it was that there was one series of commits, right? When I was like helping some students throughout the week, sort of explaining why we have the whole concept of adding and committing, one of the analogies I started using was that you imagine you're working at a restaurant in the kitchen, right? And you have a meal for some particular order. So it might be burger, fries. The fries might be ready before the burger is ready, right? So when those fries are ready, you add them to the plate, right? But you don't send them to the customer yet. You need to wait for the burger to be ready. So adding, Git add, is that first step where you've got a chunk of changes that are ready. In this case, it's our fries. We put them on the plate, but we're not ready for the waiter or waitress to take them yet. We need to also wait for the burger. When the burger's now ready, we can Git add it to the plate, and then we can commit. So committing is the moment when we say, yeah, all of these changes that I've staged are ready and they're ready to be packaged. And that's what a commit is. Now, when we look at this screenshot here, each of these circles are commits, okay? And what a branch is just another commit that falls in the sequence of commits. So if you have a look here on this develop branch, which is a common name for a branch actually in Git, it's just a commit that follows this version 0.1 commit on the master branch. And I've got a cool way of explaining how these branches work. But basically, it is still a sequence of commits that happens to have another sort of tag associated with it. Yeah, if someone, I can send the slides on because I don't think anyone else can send slides. So let me do that. How do I do that? Oops. Okay, here we go. Okay. So each commit has a parent, and a commit can have multiple children, and that is branches. So really, the commit tree is just a tree data structure. So if you've studied any data structures before, am I really dark, by the way? Let me just. Oops, there we go. So it's a tree data structure. Now, it's not the same as pointers in C. It's not like It's not a basic tree data type with just pointers. I mean, it is, that's how you can think of it conceptually, but there's a bit more going on with the hashing and things like that. And then the branches, basically there's a few ways we can think about branches. The way I've most worked with Git is the feature branch model, okay? And there are other ways of working with it. But if you can understand the feature branch model, you'll understand all of them as well. So the feature branch model, and you can see this sort of here in the diagram, is that if we're working in a group of 5, someone might be working on, upgrading one of the libraries. I might be working on making a new user interface for the app. A particular feature would get its own branch. So I would branch off some point, let's say here, this development point here, and I would start working on my feature. That could take months, right? I would have my own sequence of commits. At the exact same time, someone could be working on some other feature in a separate sequence of commits. So what it lets us do is to work on the code base on our sort of isolated track with a bunch of changes that I'm making. Once my feature is ready, I can then do what's called a git merge back into the main branch that I've merged off. Okay, for this, I actually spent a bunch of effort making a really cool sort of animation for you guys. I hope you appreciate it. Let's see. Because I've seen there's a lot of sort of misunderstanding around what a branch actually is. So here we have a terminal, right? And we have what I've made to represent some commits, or the Git sort of structure. So let's say I write program.py, I write some code, and I commit that program to py. I hit enter, and I now have a new commit on my master branch, right? That's straightforward. That's sort of what we've been doing with even the labs, right? You made some changes on the labs, you got the lab working, maybe it took a few commits, but when you hit enter, you get a new commit in that chain. And I can do that again. I can add a second program file, make a second commit, and when I commit that, we have the C commit, a new commit that falls in this sequence of commits, okay? So C has a parent of B, B has a parent of A, and I can go back in time and I can see what was at A, what is at B, and what is at C. Whoa, what did I just do? Okay. Now, it's coming to the point where I want to work on some new feature, and someone else is going to continue potentially this sequence here. Or maybe no one will continue that sequence. I just want to work on this new feature on a branch. So what I can do here is create a new branch. So the git commit, or the git, command for that is git branch checkout. Now -b means I want to check out a new branch, and then I just name the branch. So when I hit enter, you can see that actually nothing really happened. Why did nothing really happen? Because this new branch called new feature points to the same commit that master did, because I've made no changes and there are no new commits. So this is one of the things where people's mental models of Git sometimes varies from reality. People think that I made a new branch, therefore there's a whole new clone of the project, right? Did anyone think that or something like that? And maybe you've not come across branches at all yet. That's okay too. But what's really happening is that I'm making a tag with the branch name, and it just points to a commit, tracking its own sequence of commits, just like master. But I am on this new feature branch now. So when I make a new commit, I might make some new program file, I might make a new commit, and I hit enter. Here I do make a new commit in the sequence, but only the new feature branch points to that commit. Master, the previous branch, still points to that C commit. So master doesn't know about new feature. Master doesn't know that there are new commits that fall after C on another branch. All master is a pointer to this C commit. And new feature, the active branch, is pointing to this D commit. But D is just, the parent of D is C. It's still one sequence of commits. There's always one sequence of commits. It's a sequence of changes made on a project in some order in order to build out our project or do whatever we're doing. Similarly, we can make a new commit on that branch. And again, C has no idea that that exists. What have I got here? Okay, so now we're doing our merge. So this is exactly what Sienna has just asked. But don't we eventually shove everything back into master? And the answer is not always, actually. Sometimes projects just diverge. And there's two sort of, you can think of them as forks of a project. We don't need to push everything back into master. Most of the time, you're right, we do. But it's not sort of mandatory that we do it. But most of the time we do it. And the reason for that is that once this feature is complete, well, we want to release it to everyone, so we put it in the main branch. And to do that, we have to do what's called a merge. Now, how do you do a merge? Well, first of all, you need to check out the branch that we want to merge into. So that's the first thing. So this is something people often get wrong. So if you're writing notes somewhere, write them down. You merge from the branch you want to merge into. These slides, it's more like a video. So there's not really any way you can follow along these slides, unfortunately. Okay, so first of all, I check out master. So check out is the command I use to switch over and set the active branch. That's why I've highlighted them in this blue color, right? So now my active branch, I'm at the commit C. So as far as I know, all my code now would shift back to this C commit. Then I run git merge and the name of the branch that I want to merge in, and that's the new feature branch. So I hit enter, and Git really strategically does its best to merge in those changes. Now, in this case, right, it's actually a very simple merge strategy, and there are a number of strategies that Git will apply. Why is this a simple merge strategy? Can anyone tell me why? Why is this sort of easy to do for Git? I mean, everyone's got a bit quiet. Ollie, is that your name, Ollie? 100% right, Ollie. Exactly, Annalise as well. We didn't change anything on the master branch after the new feature branch was created. Exactly right. So really, all we do is apply these changes to the master branch. It's really simple. This is what's called a fast forward. Okay, we're fast forwarding the master branch with the changes that were on the new feature branch. And now you can see we still have that new feature branch. It's not gone anywhere. It just points where it used to point. Nothing happened to it. It still points to E. But now master also points to E. And so these two branches are now exactly the same. This concept applies to all types of merging, no matter how complex the structure is. So let me just answer a few questions here. What does git checkout do? Git checkout changes the active branch. So at this point, new feature was the active branch. I ran git checkout, and now master is the active branch because I ran git checkout master. Git checkout doesn't always move you to git checkout moves you to a different branch. Yes, exactly. Sorry. Okay. Zach asks a great question. Does git push do that fast forward, or do we do that some way else? Now, great question. Typically, okay, when there's merges that need to be made, but be it between a local repository and a remote repository, okay, hold on. So there's a couple ways we need to answer this, because there's a couple ways that you can do a merge with a remote repository. If I have new commits locally that I've made and I want to push those up to the repo, it will do a fast forward 100%. If it can't do a fast forward, it won't actually let me push. It will ask me to pull, fix the changes, and that's something I'll demonstrate in a moment, and then push. So typically Git doesn't want you to do a complicated merge on the push. It only wants you to do it on the pull. That'll make more sense when I demonstrate. So what was the point of this is if we could have achieved the same thing via normal commits / push. The reason we have branches is because typically different people on different teams will work on different branches at the same time. You can imagine that if I'm working on the user interface of some website, right, and someone else on another team is working on, the architecture. They're improving the architecture of the system. So on their branch, they might be breaking the core of the system, right? Because they need to pull it apart and put it back together. But I'm just working on a user interface change. It would be really frustrating for me if I'm working on my user interface and then the app stops working because, Sienna and Tom over there are pulling apart the system. So what the branch lets me do is have my isolated series where I can work on it. They can work on it, and when we're both ready at different times, we can merge into the main branch. So hopefully that answers your question. Sorry. Sienna asks, what happens if you commit but forget to push? Nothing really. You just have your commit on your local Git repository, and when you eventually push, it will apply that commit if it can. Cool. Okay. I think that's the end of my little animation there. So I think, we spoke about checking out. So checking out just changes the active branch and switches to that branch. And we spoke about merging as well. So I think now's a good time. Let me just see. Yeah, now's a good time for a demonstration. Okay. Maybe I'll just, I can just overlay it. Make it nice and big. Go away. Okay. All right. Well, actually, the first thing I might do is go to GitLab. And actually, I'll just go right to the root of GitLab. I don't want this in the project. I'm going to make a new project here. Create a blank project. I'm going to call it my lecture demo. We'll make it private. And we'll give it a README, sure. So this is something that you can do on GitLab yourself. You can do this on GitHub or any sort of Git project. So I've made some repository on some Git server. Okay, where's my code? Here it is. And hopefully you can read everything here quite nicely. Let me move my camera. I think that'll get in the way, maybe up here. All right. So I've got my little repos directory here, and I'm going to run git clone, and I'm going to clone that demo down, that project down. Now I cd into my lecture demo here. I'll clear that. I type ls. And we have that README file there. In fact, let me just quickly open this in a new code window so I have the right thing set. Oops. Okay. All right, and we've got that README file that I created on GitLab. Okay, so let's say, how do we want to do this? So let's say that I make some changes to this README. In this project, I'm going to write some awesome COMP1531 code. So I type git status as always, and I can see we've modified that README file. So I can git add the README file. Okay, I can commit it with a message. And we have that commit. I run git log, and we can see we have 2 commits here in the sequence. Now, I'm a really busy person. I'm going to pick someone randomly in my chat. So maybe Sienna. Sienna, I've asked Sienna to come help me work on this project. So Sienna comes along on her machine and says, okay, well, Sienna's going to get started writing the actual Python code. So Sienna has to work on a new branch because I'm going to work on the documentation in README. So Sienna comes along and goes, git checkout -b, because Sienna's going to make a new branch. It's going to be called add Python. Okay, and you can see here I'm on this add Python branch. But if I run that git log, if you remember, this is exactly the same as the git log from the main branch, right? Because all I did was make a new branch, so I just made a new pointer to the exact same commit. But I am on a different active branch. In fact, my terminal is trying to communicate to me here. This branch is called add Python. So now we can come along here and add a new file called python.py. Not, why would I call it that? Program.py. And I can say, you know, import sys, print, hello world, something like that. Let's see. And then I can add that. But let's say Sienna also, this is where it gets a bit more complicated. So let's say Sienna also goes, okay, well, I need to update the README file because I added, we have a Python file. And we also add that. You know, update README. Let's say at the exact same time, right? Now pretend I'm on another computer somewhere. Now what was the main branch? Was it master? No, it was main. Yeah. And if you see, like, that was a good demonstration. When I checked out back to main, I'm resetting back to this commit here, where I added the README file for the first time. If I go back to, what was it called? Add Python. You can see that it's changing dynamically because the add Python branch is on a different commit than I am. So this is where we can have multiple people working on the same project on separate feature branches at the same time. But here's the snag. What happens if at the same time that Sienna added that, I came along because I'm working on my documentation and I say, you know, this is going to be awesome. Doesn't matter what I really write here. So I write that, I add it. Keep working on README. So now we have a bit of a predicament. This is not something I showed in that visualization. There are new commits on main that my feature branch doesn't have. And there are new commits on the feature branch that main doesn't have. So I can't do a fast forward when I merge it. It's not going to work, right? Because Git doesn't know the sequence that they were added. And it will actually try and do a merge even if it doesn't know the sequence. But the snag here is that the exact same area of the same file was changed at the same time. But let's say Sienna sends me a message on Slack and says, hey, you can merge in my code now, like I've done enough. Okay. So I'm on the main branch, so I want to merge into the main branch, and I want to merge add Python. And we can see something goes wrong here. We have what's called a merge conflict. And this is something that you will come across in your project, okay? What's happened here? Git always does its best to resolve a change or a sequence of commits. But sometimes if the change is made at the same area of the file, it's not able to. And so it throws it off to you to tell Git how to fix or resolve those changes. Now, in this case, what it lets you do is it says, hey, here's the change that you had. Here's the change that the incoming branch had. What do you want to do with it? And there's a few ways. If you're using Visual Studio Code, you can just, it's got a bit of a UI here, but is there a way I can turn off this UI? I'm not really sure. But all it really does is add these characters to the file. And I can say, well, I just want both. I want there to be both. So I remove those characters and I tell, basically I'm telling Git that I want both. This is how I want the file to look. But I still have this sort of, if I check my status, I still have this sort of unmerged conflict that's not resolved. If I've resolved the conflict and I know what I want to do, it actually tells me here, you just need to run git commit. So I run git commit and, oh, sorry, I need to add them first. Whoops. I add readme because I said, okay, I've made some changes, I stage it, and then I just run git commit and I don't have to give a commit message because it's a merge, so it already has a default commit message. There's some stuff around here. Some people don't like to do it like this. Some people like to do a different form of merging. That's okay as well. So I think this is Vim. So I just save that. And then what we have here is, if I look at the log, the Git log now, we have the original commit that was made on the GitLab server. I added the README file. I added the Python file. Sorry, this was Sienna's change, right? It says Jake Manzella because it was the same computer. But you can see it's sort of merged the history of both the commits all at once until we have this merge commit. This merge commit contains the changes that resolved that commit change. Oops, how do I make my terminal smaller? Here we go. And now you can see if I run git status again, my branch main is 5 commits ahead of origin. Now origin this is origin, right? The lecture demo on the remote repository. One thing you can do, if you don't really know what's sort of going on, if you type git remote-v, it tells you what origin actually points to. So origin here is that GitLab remote server for that particular project, right? Now, someone asked earlier, well, how do you resolve those commits if you are working on the remote branch or you want to push them up to the remote branch? And this is the workflow. I've already resolved that merge. So now when I do a push, it's really simple because it's already sort of fixed up the merge. I've done that locally. And if I come over to my repo, you can see I've got those changes. Now, if anyone has any questions on that, I'll show you one more sort of thing that we do and that you guys will also be doing with your projects and the branches. But does anyone have any questions about this stuff? Chat's gone very quiet. No, seems okay. Good, I think, yeah. Yeah, look, this stuff, until you start doing it yourself, it's all theoretical and it might not make a lot of sense. So yeah, that's my biggest piece of advice. And really, in terms of learning Git, if you're working on projects, even for other courses, start making them in Git repositories. Not only do you back up your code, but you get to practice Git. So when I push Jasmine, yeah, exactly. I'm pushing my commit sequence to the remote repository and it tries to apply those commits in order. You've just got to do it yourself 100%, Zach. Okay, another thing. Let's go back to this add Python branch. This add Python branch does not exist on the remote server. Makes sense because Sienna, my alter ego that works on this add Python branch, never pushed. I never pushed. So I can do this though. I can run git push and actually I'll get a warning here. And that warning is saying, hey, Sienna, you don't have a branch called add Python on upstream. Upstream referring to where I'm pushing to. And that makes total sense. GitLab, this remote server never knew that a branch was created. Even though those commits are on the main branch that I push to, that was after a merge, so it only knows about them on the main branch. But it doesn't know about them on my branch. But it's telling me, if you want to do that, you can actually create that branch remotely and then push. And there's one nice command here that we can use. So what is this doing? Do a git push, but also set the origin upstream, and we know what origin refers to because we just saw it, as add Python. So basically make a new branch on the remote and push up these changes. I hit enter, it's going to push those changes. We refresh on the repository and we can actually see here that we have that add Python branch. Now, if I look at README on the main branch, you can see we've got those 3 lines here because I made the 3 changes, did the merge, etc. What am I going to see when I click this add Python and I view the README? Everyone? And if you're watching this lecture afterwards, you know, on YouTube, on your phone or something, you can sort of answer in your head. What should you see when I click add Python and I view the README? So I guess, yeah, the 3 lines in the README or the 2 lines in the README? Now I've switched to this branch. We got any answers? Andrew, 2 lines, 2. We've got the 2 because the add Python branch only pointed to the commit that Sienna recently made, which did not know about the other changes that happened on the main branch. So you can see I've got sort of 2 copies, or really branch is the best word. I've got 2 branches of this project that exist simultaneously. Okay. Now a couple more questions that were really good. What happens, so this is Justin, what happens if there are more than 2 branches which need to be merged? Absolutely a great question. 99% of the time I say that with absolutely no factual evidence. But most of the time, you always do a merge on 2 branches. But you could have, 50 branches. You just pick 2, do the merge, get the 3rd, do the merge, get the 4th, merge it in, get the 5th. You do them branch at a time. There is actually a octopus merge. I'm not joking. That's what it's called. Where you can resolve a merge between more than 2 commit heads at a time. I've never used it. I don't really understand how it works. I get it if there's no merge conflicts, but I guess like in theory it makes sense. But it does exist. I've never seen it used. I don't know why you wouldn't just merge one by one. Maybe if you had a huge amount of merges that you need to do or something weird like that. But it does exist and it's got a cool name, the octopus merge. James has asked, do you need to pull other people's branches from the online repository in order to merge? Absolutely. Absolutely. And actually that's a good point. Whoops, I didn't mean to do that. That's a good point. Let me show you something. How do I make a new branch on GitLab? Oh, okay, yeah. Here it is. There should be a way to do this. Click branches. Was there really a button? No, I don't see it. Oh, new branch. It's up here. New branch. Okay. So some remote branch, and I'm going to branch it off main. So let's pretend here that someone else is working on the project, and they've created some remote branch off the main branch, and they've pushed it, right? It's on the upstream. But if I look here, whoops, again, I've clicked the wrong thing. If I look here, running git branch shows me all the branches I have. I don't have that 3rd branch, right? So how do I get it? There's a command called git fetch. That didn't work. Git fetch origin. Why is that not working? Git fetch upstream branches. What have I done wrong? Is it upstream? Is that what I need to do? Git fetch upstream? No. Yeah, because it's called origin. So I thought it would be something like that. No. I don't think you need to fetch from the main branch. That shouldn't make a difference. Oops. So maybe all branches. So the difference between fetch and pull is that fetch just fetches the new branches and pull actually pulls down the changes, if that makes. Oh, git fetch all, okay. Still not there. That's weird. Let me make a note and come back to this. I'll post an update. I don't know why that's not getting that branch. Oh, maybe I do need to do a pull. No. Oops. Yeah, but I thought it would give me access. I thought it would show me that the branch was there. List remote branches. Okay, that sort of worked. That showed me that there is this branch on origin, and then I can probably do git fetch, paste that. No, I don't know what's going on with that then. Okay, that worked. I had to give it the exact, so I can do, let me get that cleared out. Git fetch origin, some remote branch. Now when I check my branches, it will exist. But I thought that, oh, it still doesn't exist. I don't know. Okay, I understand what's happened here. Okay, sorry everyone. You need to check out the branch before it exists, I guess, on your local repo. I didn't actually quite know that, to be honest. So Git knew that I had that branch fetched, but because I had never checked it out, I guess it hadn't had a necessity to list it as an active branch on my local repository, if that makes any sense. That's why I assume that's happened, but maybe I'll try follow up when I get more details on what's happening here. I mean, this is the thing with Git, it's a complex beast. No one knows all the inner workings of it, and sometimes it can behave differently based on different versions of it and different remote servers and all that stuff. But that's typically how you would, I mean, it is typical that you know the branch that you want to pull in because someone tells you, hey, my branch is on remote and it's ready to be worked on. Here's the name of it. So you pull it down and you check it out. So once you check it out, then you can see that I have my branches here. There's probably some flag to Git branch that can show the inactive ones or something like that, and I just don't know it. Cool. Let's go back to these slides here. We spoke about that. Okay, we spoke about also that there are a few different types of merge strategies when I merge branches into each other. And so here's a nice little table that you can look at, and I'll give you the PDFs to all this at some point. And you can see, okay, if I've got two branches, right, some feature branch, and then the master branch or the main branch. If there's no changes on either branch, then there's nothing to do, right? There's nothing to merge because they are the same branch. They're the same commit. If I have changes on my feature branch that I don't have on my main branch or my master branch, we check out that main/master branch, and then we run git merge on that branch name, and we do a fast forward. This is what we did in our first sort of demonstration. If I have it the other way around, so there's changes on main but not on the master branch, and I want to fast forward the feature branch, I check out to that feature branch and I merge in the main branch, and that will also fast forward in the other direction. And this is what I demonstrated in the last example. If I've got changes on both branches, well, either there'll automatically be a merge commit because it knows how to do a merge, or you'll have to manually resolve the merge conflict and do the merging yourself. So they're the common scenarios you have when you're merging in two branches. Okay, let's do a merge request. Merge requests are also something that you need to do for the project, and they're most commonly, I'd say they're referred to as pull requests. That's what GitHub calls these. On GitLab, they call them merge requests. To be honest, merge requests actually makes more sense. So rather than just merging in a bunch of changes to another branch, a merge request is when you're working with other people and you say, hey, I want to merge these changes into another branch. Can you take a look and let me know if these look okay? This is a really common way that we work on code. Okay, so let's come here. We can work on this remote branch. I can make a change. Let's just make some random change. I add the program file, I commit it. Oh, sorry, Richard, they're exactly the same thing. Just GitHub calls them pull requests. GitLab calls them merge requests. They're exactly the same concept. And Sienna's right. It's a quality control step. So I'll explain about the merge request review process when I get to it. But I make some commit here, more progress on my file. I git push. Now the origin already exists on the remote branch for this branch, so it's just able to push. Now if I go over to GitLab and I go to that, here we go. Now you can see GitLab's really helpful. And it says, hey, you recently pushed to a branch, which I did. Do you want to create a merge request? Yeah, I do. Okay. This is the user interface for creating merge requests. Now, merge requests are GitLab/GitHub features. You can't do a merge request or a pull request in Git itself. This only happens on the UI, on the server itself. So basically it's saying you want to make a merge request. All right, where do you want to merge from? Some branch that I'm working on. Where do you want to merge to? The main branch. I can change that. I can merge to some other target branch, but this is fine for now. What do you want to title this? By default, it's just picked the last commit, but I could usually you would write your own commit for this. So adding more changes to the program file. Okay. What's the description? This is something you will need to do many times in your project. Describe the changes that happened in this sequence of commits. Now, in this case, I've only got one commit, but you could have multiple. So describe these changes. Okay, well, all I did was add a second line. Pretty small merge request. That's a bad description, right? But you understand if you had multiple changes that were working towards something, you would describe them here. Okay, assignees are pretty cool. So in your group of 5, you might have someone who's got a really good understanding of the API and someone who's got a really good understanding of the data store. So if you're making changes to the API, you say, well, I'm going to be working on it, but I really want, Sienna. Now, if Sienna was part of this project, her name would pop up here. I really want Sienna to look at this and to approve it. So the reviewer is the person that approves these changes. I don't think we really do anything with milestones. These are like a project management tool. You've got some options here. Hey, after you merge in the branch, after it gets approved, if it gets approved, do you want me to delete the source branch? This is a really useful feature really harkens back to the feature branch model. With feature branches, once the feature is complete and merged in, we don't need that branch anymore because the feature's complete and it's rolled out. So it's just giving you a handy option. Do you want to automatically delete it? And sure. We're not going to worry about squashing commits right now. And I create that merge request. And now we have this open merge request on GitLab. And if I'm Sienna now, the reviewer comes along, they get a notification. I don't know why I looked at my watch. And they come along and they say, look, oh, okay, here's everything that changed in these commits. It used to be one line that said hello world. Now it's 2 lines. It says hello world and then the second hello world. And the reviewer needs to think and look and say, hey, are these the changes we want? Does this complete the feature we wanted to? And is this going to break the project? Is this bad code? Now, in this case, it's pretty glanceable. You might come back and say, yeah, I approve this and it's ready to merge. You might think, oh, there's a few too many changes here. I need to actually check this branch out myself, run it and make sure it works. I can do that. But generally, once the code's up to scratch, you might have a discussion. Hey, you need to fix X. After you have some discussion, you can approve and even merge that code in. GitLab does that merge itself. It knows if it's ready to merge or not. And when I go back to the repository, let's see here. Oh, I can just click here. We merged into main, right? So we have that second line so that this merge happened remotely. And that's a merge request. So it's a quality control process that happens to make sure that people aren't just going nuts and merging a bunch of different code into the main branch or to some branch that's going to break your project. Okay? Okay. Brandon, I just realized that the YouTube stream is incorrect. Oops, sorry about that. I'll try and fix it. Scooby Snack, whoops, says, I'm lost. If you can let me know what you're lost about, maybe I can help talk about it. Yep, exactly. We're preventing code murder. In the table, shouldn't the fourth one be yes/no? Whoops. What am I looking for? No, wrong one. Is it a different? Where did it go? Have I gone blind? Oops. Where was that table? Ah, here was the table. No, that's a different, anyway. No, this is meant to be that there are commits on both the branches. There are different commits on both the branches. I do a merge. I will need to either do a manual merge conflict resolution or it will be able to automatically merge. So that should be yes and yes. Yeah, look, guys, all the Git stuff is, until you're doing it yourself and you get familiar with it yourself, it will be complicated. Git is complicated. There's just no way around it. You've got to practice. And when you practice, this is why we use it in the project. This is your opportunity to learn, to ask your tutors, to ask me. We discuss it, to practice in the project. And so when you go out into industry, you're not spending the first, oh, you meant, there were 5 columns. Do you mean rows? I'm confused, Andrew. I may have changed Hayden's slides a little bit. You might have a link to Hayden's slides. That might be what's happened. I've got to update the link. Yeah, that might be what you've got. That makes sense then. Yeah, and there was an issue with Hayden's table, which I fixed here. So look at the one that's on the screen. This is the one that I'll make the PDF from, that I'll give you. Okay, that's probably resolved your issue. Okay, so I think that's everything for this lecture. Yes, guys, I'm with you. This is I don't really think the best way to learn Git and to understand it is to listen to a lecture, truthfully. You've got to just start doing it. And when you get stuck at things where it doesn't quite make sense, that's when you can seek help on the forum or from your tutor or from whatever. And then you get unstuck and you'll learn it a little bit better and you'll make progress. But if you want to go back and refer to this lecture later on when you're getting more in the thick of it, hopefully it'll be helpful then. But I do understand it is complicated. It's just the nature of the beast, I think, unfortunately, with this one. Okay, as always, if you think things that you liked or didn't like about the lecture, there's the feedback URL. We're going to have a 5-minute break, and then we're going to talk more about some Python stuff. Remember, again, regarding the project, to watch the YouTube videos that were pre-recorded that describe the specification and the project itself. Does anyone need these sent in the chat again? Yeah, it is just hard to understand the first time. You know, with Git, so I never learned Git in my studies. It wasn't taught in my computer science degree at my university at all. And the first time I used Git myself, let me go to my talking cam. The first time I used Git properly was in my first sort of gig. Sorry, by gig I mean my first job. And it was really stressful because you're starting your job for the first time. You're insecure about your programming and software engineering abilities anyway. And not only are you trying to get your head around a code base, you know, that's complicated and old and falling apart or whatever, you've got to learn Git. And it was really stressful. And it took a long time for me to build the confidence in using the tool. So you're going to go through that sort of anxiety about Git as well. Everyone, I think, does. But the cool thing is that you're doing it in this environment where, yeah, it's related to a course, but you've got all this support and you can ask those stupid questions that you might feel embarrassed to ask in industry. So yeah, it's normal. I'm with you guys. We're here to help. We'll help you out. Was my first job the security thing? No. My first job was just at a software lab. So it wasn't anything like that. What was my first project? I think it was called Maestro, and it was I think it was like a Kanban tool. It was like an internal tool. It was like Trello, basically. We're building our own Trello. I don't know why we didn't just use Trello, but it was something like that. Maybe it had some specific features or integrations that we wanted. So it was an internal tool for all of our projects at the lab, basically. In hindsight, they probably were. It was like a bit of a learning activity that they threw me on, which makes sense. So my bachelor degree, I studied at Swinburne University in Melbourne. It was actually a really great degree. Really good lecturers, really good course. Yeah, really hands-on, learnt a lot, very good. Had a great time. Yeah, all of that. Okay, people wanted the links again. Let me see. Well, let me show you where to get them. So if you go to your project repository, you can see the repository here. In this section 2 overview, there's 2 links. I'll copy them. There's my mug. Oops, I didn't want to close that one. So there's link 1, and there's link 2. But they're just in this, the specification. So that, you know, they're pre-recorded, they're really well done, and they take you through the project, both the specification in part 1, and then how to actually get started. And Hayden actually, in the video, get started writing code for the project. So it's really important. If you want that project help, you can watch that video. Should we play some music while we have our little break? So how are you guys going? Talk to me. Dreary day outside, no trains running. What's everyone up to? Git is hard, 100%. Git good. So much rain, rain is good. Yeah, it's better than the fires last year. Or was it 2 years ago? Cramming work and lectures, yeah. You guys work. Oops, I'm on the wrong. You guys work too hard. The loudest thunder. So many instructions making me confused. One thing that I used to use to help me learn, oops, desktop. You can find these Git cheat sheets. Oh, there's an Atlassian one. That'll be cool. Yeah, this is good. I actually, when I first started getting into it, I printed this document, something like this at least. Oh, that's not what I wanted. Let me just link it. Let me link you here. I printed this something like this out and I laminated it. So I printed it double-sided, laminated it, kept it on my desk. And when I was working and I was confused about what something did, or I wanted to learn what something did, I could just sort of, all the common stuff was here. So you can see, you know, and this is only just scratching the surface of the amount of commands that Git can support. But this is a good little guide. Yeah, rain is quite sentimental. I get what you mean. Okay. Let's get ready for the second part of the lecture. The other thing with Git, guys, is just Google. You just Google how to do things, you know? Okay, that's that. We don't need that. I think that's a funny. I'm inclined to believe that Git developers use Git to manage Git development, and that scares me. Not only that, Richard. So like, I mean, yeah, I'm sure that they do, but like, so when software languages get written, they get written in another language, right? So if I'm developing the Python programming language, I might start writing the language itself, the specification for the language, in something like C. That's common. At some point, when the language that I've written in C gets mature enough, I switch to continuing the development of that language in the language that I wrote. Does that make sense? So like Python gets developed in Python now. But for example, the C compiler at some point was not compiled in C because the C compiler wasn't ready. And then at some point the C compiler was so good or good enough that they could compile the future C compiler with the C compiler. How's that for a... Because like the C compiler that you run is just a program that had to be written in a language. And before the C language was written, you couldn't run the C compiler to compile it. So you had to run it in some other language's compiler. But then at some point, the compiler was good enough that you could compile the C compiler in it. Yeah, recursion. Crazy. I know. Programming is crazy. Okay. But that's, I think, you know, programming, it's really engineering, software engineering, it's the coolest thing ever. It's really cool. Okay. The third lab should already starting to be released right now. Alrighty. Sorry, I've just turned the music off. I assume it'll be distracting. Alright. Desktop, let's see. Cool or a headache? Bit of both. Okay. Oh, this is the wrong lecture slides. Awesome. I want 2.2. Okay. Yeah, I can link to the Spotify playlist, no problem. With the lab choice points things, do you get more points the more you do? So no, Daniel, it caps at the number of choice points for that week. So you can do more, but it's just extension for your own fulfillment. Okay, I'll share the playlist, and then we're getting going. There we go. Alrighty, so back to some Python stuff for the second part of the lecture, and we're talking all about collections today. So what are collections? Collections are the in this lecture, collections are the set of core Python data types or data structures that we have available to us to store data in the right way for the right set of data that we have. Okay, there's 4 basics of data structures in the Python language that we get by default: lists, tuples, sets, and dictionaries. We spoke about all of these except for sets a little bit in the last week's lectures. In this lecture, we're just going to go into a bit more detail and talk a little bit more specifically in terms of the project as well. Okay. So, what is a collection? A collection is also like a list. Well, a list is a collection in Python. You're typically used to collections as being arrays in C. Now, what makes a collection a collection? A few things. Number one, we access the indices by some integer index. So if we have a look at this screenshot down here, 0 is the index and it refers to an element in the collection. 1 refers to the second element, 2 refers to the third, so on and so forth. You're familiar with this with arrays in C, right? But what that means is that these collections have an order. And the reason why this order is so important with lists and other collections like arrays is that the memory to store a list is a contiguous piece of memory. If you've heard that term before, you'll know what it refers to is that the memory for each element in the list or the collection falls directly after, sort of physically in memory, than the previous element. So it's one big block of memory divided by the number of elements inside it. But it's not like a linked list where they are just containing pointers to the element somewhere else, right? So it's one block of memory. Lists in Python tend to cover the classical usage of both C-style lists and C-style arrays. So lists are sequential. Didn't I just view that slide? Okay. So again, there's nothing crazy happening with these lists in Python. They basically are arrays with some helper functions around them. So let's look at some code. All right, so here's another example. Now, I know we went over this a little bit last week. We'll go a little bit deeper this week. But really, it's just for some exposure and for some practice. Okay, so here I've got a file called list loops. We have an array here. This is how we have a list, sorry. This is how we define the list. So this list has 4 elements. A is the 0th element, B is the first element, etc. My list is called items. Here's one way, if I want to loop through all the elements in my list and print them out, here's one way I can do them. Let's break this down a little bit. Items refers to my list, that's A-OK. Length of a list gets me an integer that represents the number of elements in the list. Okay, so in this case, this would be like 4, right? So this would evaluate to 4. Then we have this range function. What does range do? Again, we spoke about range last week, but range explodes a number into each element. So range of 4, let's comment this line out, is kind of like saying 1, then 2, then 3, then 4. Actually, no, it's not. Sorry about that. It's 0, then 1, then 2, then 3. That's the range. It's 0 up until 4. And so you can imagine that what it's really doing here is assigning I for each element in the range, okay? So I will start at 0, and I can sort of show that off here. I will start at 0, then it will be 1, then it will be 2, then it will be 3. And then this is exactly like C. I can use that index to look up my array or list and print out the correct element. So if I run this, oops, what did I just do? That should be Python. If I run this out, you should see I get 0 is A, right? 0 is A, 1 is B, 2 is C, 3 is D. Nothing crazy happening here, right? By now, I would say that you guys should be comfortable, at least comfortable with how this is working. The range is a little bit funky, but like I said, it's just exploding a number into a sequence and then iterating over the sequence. But this is not a Pythonic way of iterating over a list. So this is how we just did it. This is an even better way of doing it. We don't need to stuff around with creating an index and then just all we use that index for is to look up the array. We don't need to bother doing that. We can directly use the built-in syntax of Python to assign the value of a list to each element when I loop over it. And we use the for-in syntax just like we did here, but rather than assigning it the range, we can just assign it the values themselves. So here, item in items represents each item. That was confusing. But I run this and you can see, okay, I'm doing it twice here because I'm printing it the old way and then I'm printing it the new way. Let me do something like that. And you can see I get A, B, C, and D printed. I don't know why I read it backwards then. I get that printed in order. And you can just see, right, it's just cleaner. What's easier to understand is I is assigned to the length of the array turned into a range, and then I use that index to look up the array, or item is just each item in the list. So yeah, range and length, you can see here there's no imports. They are part of the standard library in Python. And specifically, they are part of the iterators or dealing with the list data structure or sequential data structures like lists. Okay, now, no one's asked this, but I wish someone did. No one said, but okay, Jake, if this is such a superior and cleaner method, you can probably agree, yeah, it's cleaner. But sometimes when we loop through collections, like a list, we want the index. Do you guys agree? We want the index sometimes. We need it. We might need to literally just print the index, but I can't print it here, right? Is this going to work? Well, it might work because it'll be assigned from here. But now it's not going to work. There's an error. Eyes on top. How do I print my index? Well, we can do this. So what we can do is we can call this enumerate function over items, and we can do what's called a is it called an explosion or something? It's in the slide in a moment, but we can break down what enumerate returns into basically a tuple or a destruction of the things that contain this enumerate. So the first thing we need to understand is, what does enumerate do? Well, enumerate, let's see what the documentation says. It returns an object supporting iteration. It yields, okay, so it sort of returns a pair containing the count from the start, which defaults to 0. Whoops, I just moved my mouse. And the value yielded by the iterable argument. Yeah, destructuring, yeah. So we take this items list that doesn't know what the index is. We enumerate over it. But enumerate, as well as returning the value, like A, also returns the count. So A is 0, B is 1, C is 2, D is 3. And then we can use this really cool Python syntax with the comma in between two variables. And enumerate will actually assign both the index and the item from the yield. And then I can print them. How cool is that? Let me comment this out because you've already seen that run. Now this is number 3. Look at that. I have my index and I have my value. And it's all packaged in this sort of nice Python syntax. And I'm not stuffing around with, items, bracket, index, although I could do this. I could do this absolutely right now. But I don't need to automatically assign it to item. And you're not going to have off by one errors where you use index one too many times, etc. And yeah, you can use this just to print the index. Absolutely. I mean, this is just a print line. Index is just a variable, right? 0, 1, 2, 3. But I mean, if you only wanted the index, it probably would make more sense to do, for index in range of length of items. This probably makes more sense if you only want the index. This probably makes more sense because you don't have to actually enumerate over the elements in the list. And if it's a long list, this would probably use a lot less cycles to complete it. But sometimes you want both, and this is the syntax for that. And again, guys, like always, all of this code is available in the repository. Question here on what this F syntax says. This is an F string or a formatted string. So it's just showing how I want the string to be formatted. And so this is why we get the colon. So we get the first variable, evaluate it, get its value, then put the colon, then put a space. It's just like the C printfs in C. Okay. Let's talk about tuples. We spoke about these again last week. They are read-only values. They are immutable values. Once they're set, they can't be changed. And the syntax is really similar to arrays. However, we use a normal brace rather than a square bracket. In terms of when we use them, typically we use them when we have a collection of different types and the collection is of a fixed size. Okay, so let's look at some code here. And let's look at some more destructuring syntax with our tuples. This is a really cool feature of Python. So here we have some tuples in another array, in an array called items. So we do have an array here, and inside the array we're storing 3 tuples. Okay, hopefully that makes a bit of sense. And the tuple is a pair of an index, it's not an index, it's just some value, an integer, and some value, a string in this case. Now, we want to deal with these. How do we deal with these? Okay, well, here's a lazy, or not lazy, here's the C thinking way of doing it. The COMP1531 thinking way of doing it. We can loop over the items, and then, so this is using the cool sort of Pythonic iteration method. In this case, item is going to be assigned, the first instance, 1 and then A. That's the tuple. I can use this, the same syntax we use for looking up a an array by using 0. Now, what's this 0 refer to? Why is it always 0 and always 1? Well, 0 is always the first element and 1 is always the second element. Tuples always have only 2 elements. They are a pair. I'm sure there's some etymological relationship between tuple and 2. I mean, they also sound similar. But this is why we can do that. So the 0th element of the first tuple is 1. The first element of the first tuple is A. And then I print those out with an F string again. Now let's comment this out and run this. Now this is, what's this called? For-destructuring. Now we haven't destructured yet, but you can see here that I get, oh, I didn't comment this out at all. Oh, it just went down too low. 1 is A, 2 is B, 3 is C. There we go. 1 is A, 2 is B, 3 is C. That makes a lot of sense, but the syntax is a bit clunky and it's not using the correct Pythonic way of dealing with this data structure. Now, just to remind everyone, because I saw a question here, this is a tuple here. I'm storing my tuples in an array. So it is the right syntax here. Okay, let's come down here and look at another way we can deal with our tuples. So again, we iterate through our array. So just to clarify, items is the array. Each item is a tuple. Okay, I loop through my tuples. So each item is a tuple. And here we have that same destructuring syntax that we used in the enumerate example. So when I loop through a tuple, I can automatically destructure the pair into 2 named variables, name and character. And now I don't have to stuff around now with these syntaxes and these lookups. It's really neat. And then I can just print that out. So let's highlight this code. Sorry, comment it out and run this. And again, I get the exact same pair. And if I want to change the string format to put a colon in there, I can do that just like we used in printf in C. Okay. We have one more example. Now, what's the difference here? Okay, this is really cool. Here I destructured my individual tuple. Let me uncomment it. After I iterated it through the array, right? In this example, I'm actually sort of pre-destructuring it when I iterate through my list of tuples. I mean, it's crazy, but it's so cool. Because look how minimal the syntax is. And it's just much more expressive. I can just say, hey, for each number and character in my items, print it out, dude. And that's what it's doing. Now, yeah, someone mentioned, can tuples have more than 2? Maybe they can actually. Let's put a second string there. They might be able to, yeah. So it's just a dynamic preset list. And in that case, this is a good argument, a good demonstration that I'd be able to just put car2 and destructure it multiple times. Let's see. Yeah, that works. So this was wrong. They have only n elements, but again, they're immutable, so I can't change the length of this tuple once it's been created. But yeah, this destructuring can happen for up to n elements in my tuples. Really, though, most of the time I've seen tuples, they're just for 2 elements most of the time. Any longer, and you're more likely dealing with a sort of dynamic list where you would make it a list. But yeah, but this is what we're talking about here. The point of this is the destructuring syntax, which is a really, really cool feature of Python. Cool. Okay. Can you have tuples within tuples? I think you could. Let's see here. Maybe not. Well, let me get this out. Oops, fix that syntax up. So there's a tuple, and then it could be an integer there. So yeah, it looks like you can. If I print val, yeah, you can have a tuple inside a tuple, just like you can have a list inside a list, right? Okay. Yes, you can. Thank you, Hamish, for that cute syntax. Sam's asked, what if you do number, comma, character? Okay, great question. So let's delete this. This is a great question. This tuple has, each tuple has 3 elements in the set. What happens if I destructure it with only the first 2? You can say, well, first of all, we won't have a variable for this. What's it going to do? What do we think it's going to do? What do you think it's going to do, Sam? Or anyone? Okay, so Ollie reckons it's going to get angry at us. I don't reckon it will, personally. You think it's going to go AA? Or you think it's going to go 1 and then a tuple with AA? That's interesting. Dion thinks it'll just ignore the third one first and then the tuple. Let's see. There you go. Too many errors to unpack. Is that the right line 17? Yeah, can't do it. It expected there to be 2 values to unpack, but there were too many. There were too many. Oops. But what you would do if you just wanted the first 2 is you could destructure all 3 and just not use the variable. That would be the sort of solution to how to actually deal with it. And I think similarly, if you tried to do too many, you'll also get an error. So Ollie was right. Okay. Alrighty. Yeah, I just did that then. You still get an error. Oops. It's the same sort of error, just on the other side. It'll be, not enough values. It wanted 4, but there was only 3 or 2, whatever. Okay. All right, let's talk about dictionaries. Dictionaries are really cool. They're the most, I would say, the most used data structure, maybe with lists, in Python. So dictionaries are associative containers. What does associative mean? It means we associate a value with a key. That's all associative means. Or we map it, a value to a key. In newer versions of Python, dictionary keys do have a sense of order. There was this whole kerfuffle with old Python that the order of keys in a dictionary was not consistent, and that resulted in a lot of problems. And in the change to Python 3, they made it so that the order was sequential and was consistent across time. So let's look at some stuff here. Let's go to, it's my dictionary example. All right. So here I've defined a dictionary. So the chat's gone a bit weird. We're going to ignore that. Here we've defined a dictionary with the 3 elements of associative key pair values. So name is the key, Sally is the value. Sally is associated with name. Sally happens to be a string, name happens to be a string. Okay. in this example, 18 is now an integer, but that's fine. We associate the value integer with age 18. Okay, can anyone tell me why we keep a comma at the end? That's cool. This is called 6. I must have skipped the number 5. So people say so you can append more values. We can append values even if we don't have the comma here. Nothing's going to stop me from, changing that. Maybe so you don't forget later. Getting close. It's a real. If anyone gets the real reason that we do it, I'll be very impressed. Comma denotes the end of the defining part, so we end with the comma to say last bit's done. Nope. I'll give people 20 more seconds. And if you're playing along at home, I will be very impressed if you get this. No, nothing like that. So the reason we do this in Python, and we do it in JavaScript as well, it's something you see in JavaScript. So some of you are sort of on the right track, but you've said because we may add more later, and that's correct. We may add more later, but again, it doesn't help me. It doesn't do anything in terms of the language. It's just that we know that in the future I might have, some other key value. So why do we do it? Well, let's say oh my God, I just heard the thunder as well. Jesus. Let's say I commit this code to GitLab. Okay? Well, let's say I commit this code to GitLab. Okay? Now, in the future, I come along and I add a new element. How many lines changed? How many lines changed? Forget about the thunder. Come on. 2 lines. Yeah, Jocelyn, exactly right. 2 lines changed. Because I had to change this line by adding the comma, and then I had to add the second line. Now, let's assume that I had the trailing comma. This is a big brain moment. Yeah, this really is a big brain moment. And I add the second line. How many lines changed? Only 1 line changed now. There's just 1 addition. Now, when I'm at my GitLab repository and I'm looking at my merge requests, here we have 1,500 merge requests, and I look at my changes, how many colored changes will I see if I have the trailing comma? There will be less noise. There will be less changes. There is less changes. There's less changes for Git to track. There's less opportunity for there to be a merge conflict. And it's more simple for me to look at the changes here and go like, oh yeah, we've just added this line. Yeah, that is a really big brain thing, but it's an easy habit to get into. Okay, so let's forget about that now. We can leave the trailing comma. Basically, Python is just smart enough to say that, yeah, even though there's nothing coming after it, I'm going to let you keep the comma there. Really cool. I print out this dictionary, and we know that this is just how Python works. When we print out the built-in data structures, it builds the syntax for how to print those out. So it puts the curly brace and it prints out the contents in the correct order. And yeah, that's the basic dictionary. The dictionaries are going to be what you use for the core of the project. So we actually use what's called a data store, which is just a dictionary in the project. It's just a key value, a sequence of key value pairs. Okay. All right. Next example on dictionaries, getting a bit more advanced. like anything, I can store a dictionary value in a list in Python. We can store anything in a list, really. In this example, I've got my user data storing a sequence of dictionaries. In this case, I've got these two dictionaries here. And the dictionaries are just the same. It's a name, an age, and a height, key value pair in a sequence. So how do I loop over that list and deal with that dictionary? Well, just as you'd expect you'd be able to. For user, in my user data, so in my list, we get user assigned to each value in the dictionary list, and we can just print it out. Now this is 7. It's a bit hard to see here, I understand, but we get the first user printed out, and we get the second user printed out. Okay, nothing crazy going on there. Well, what's actually happening here? We loop through, we print the whole user, and then, okay, sorry, I did miss sort of the second part when I was talking. First of all, let's just comment this out. We print the whole user out. Okay, that makes sense. We're printing the whole object, the whole dictionary. Then what we can do is, rather than print the whole user out, we can actually print each component of the user. So each part of the user, print out the part. What is the part? Well, the part is the key. So really, this is like saying print the key. Oops. Print the key out. Name, age, height. Name, age, height. Why are they there twice? Because there are name, age, height in the first element, name, age, height in the second element. Cool. How would we get both the key and the value out? That's all about this second example here. So here again we have, well, we're going to build up to it. So here again we have a single dictionary, name, age, and height. Let's comment all of this out. I'll answer your question in a second, Carmads. Whoops. Oh. This is now 8. All right. So how do we do, what's going on here? User data is our dictionary. Items returns, let's highlight over it, see what it says. A set-like object providing a view on the items. So it returns a string and then any, which is the value. So if we print that out in our list, what we're getting is name is Sally, age is 18, and height is 186 centimeters. And they're basically being printed out as tuples. Okay, so .items gets each individual set, okay, in the dictionary, and you can iterate over the pair. So I could then say, well, then I want to just print user 0, which is going to print out what? That should just print out the key, basically. Name, age, and height. I'm printing both there. That's why both are coming out. Now, again, you should start getting the theme here. Python's all about avoiding the need to get into the nitty-gritty of the data structures. So does it give us a way to get the keys out? Yeah. And what's it called? Keys. I mean, that's Python, right? It's being helpful. So if I print this out, we just get the keys, name, age, and height. So this and this are equivalent. Right? So if I want just the keys, I can use the keys. If I want both, I can use items. And if I want just the values, of course, we have values. I print this out and I will get just Sally, just 18, and just 186. So these are all the different building blocks we have to dealing with when we want to iterate over our dictionaries. So any questions on this dictionary stuff? Now, there was a question, what does printing look like without the F string? I mean, so you can see here, like, I mean, let's comment. I don't know why I did that. Here, there's no F string, right? It's just user. user is actually let's just to keep it simple. Let's do this one. Here, user is now going to be the value, and there's no f string there. We just print it straight out to the terminal. If I did have a string, if I did have a string here, the value is, I can do this plus here. Now that might not work in case one of them is not a string, so I can convert it to a string. And you can see that this is the equivalent of not using an f string. But so you can already see how the f string is sort of superior. So I can turn that into an f string. I don't need the plus there. The whole thing is a string. How do I dynamically evaluate user? I can just wrap it in a pair of curly braces. What makes, what's neater? Definitely this method. Okay, some questions, question time. I don't know if I missed it, but if I have more than one piece of user data, so Sally and Bob, how do I specify which one I want? So do you mean if you've got an array of 2 dictionaries, Zach? And that's right, car mads. It just always calls basically str on the element automatically. Okay, so if this was an array, I mean, we had this in example 7. We have an array of dictionaries. We have name is Sally, name is Bob. The question is, how do I specify which one I want? Well, the answer depends. What do you want? Do you want the first dictionary? Or do you want the dictionary where the name is Bob? Why don't we, in the last 10 minutes of the lecture, why don't we sort of solve both of those use cases? So let's say I want the first dictionary in my list. Well, I mean, it's a list. It's a list. Let's comment this out. It's a list. There's the first element. Let's print that out. There's Sally with the age, with the height, just the first element. Okay, the other example. What if I want specifically, I've got a big list here, and I want to find Bob. This is something that you'll definitely be doing in your project, something like this. I want to find Bob. Well, okay. Well, first of all, I got to loop through. This is just like C, right? There's no magic here. I got to loop through all the elements in my list, okay? And I want to find the element where the user's name, this is a string, is equal to Bob. If I find this, I can say, hey, let's go print, do an f string, hey, not a capital F, lowercase f, hey, I found Bob. And I'm going to call that user. Let's get rid of that. Let's get rid of that. Let's see how this goes. Is this file 7 correct? And there it is here. There's the element with the correct element. So we looped through. At first it found Sally. It checked Sally's name. Was that Sally? No, it wasn't. Sorry, Sally is not equal to Bob. We go and check the next one. Is it Bob? Yeah, that's Bob, I found it. And here's the element that refers to that dictionary. Does that answer your question, Zach, was it? So this is where all the different concepts that we start talking about sort of come together, and we can sort of piece them all together to do what we want to do. Cool. Crystal clear, fantastic. That's all I can hope for. Any last questions? Let's see actually what is left in the slideshow. We spoke about we spoke about the dictionaries examples. Now, there is also this concept of sets. We may have seen them before. We don't actually use them in the project or this course. If you want to read more about them, you can cover them here. Let me send the link. But other than that, we don't actually talk about them. Now let me just get up. I just need to get the feedback QR code because I didn't update. There we go. I missed the first half of the lecture. Can you do it again? No problem. What a scalable approach. Jasmine, just to confirm, when you do 4-key user, sorry, let me see, which one are we talking about? Just when you do the 4-key in user, print key is key a special print thing. Someone help me, which file were we talking about? Or did I rename something? It's just a random, it's just a random variable. Yeah, it's just what I called it. I wanted it to represent my key. It's a shame I've lost where we were talking about it. I think maybe like this keys function is reserved. That's the function called keys that gets me back the keys. But if I was just destructuring it, I just chose to call the first one key because it was the key. Yeah. At the bottom of 7. Okay. Sorry, because everything's so zoomed in, it's really hard to. Yeah, I might have like. Okay, I did rename it. Yep, there we go. Yeah, I've called it key. This could be anything. Basically, if I have a dictionary, right? So let's do it another way. So first dictionary is the is Sally 18186. If I go for key in first dict, seven, yep. It's printing the key, but again, this is just when you loop over a dictionary, it by default loops over the key. So I could call this anything. And you get the keys there. But it makes sense to call it key because that's what it is. Okay. I don't know why, but dot items and dot keys don't work for me. Yeah, not sure either. Make sure you've got the brackets afterwards because you're calling a function, and make sure you're using Python 3.7 and not some other version or a modern version of Python. Yep, so there, how does Keynote use the first bit of the tuple? Do you mean right here? This isn't a tuple. It's the key value pair. Yeah, it's just doing it by default. It just gets the key. Yeah. Unless I specify I want, not the key, basically. Would print user data 00 work? Let's find out. I don't know if it would because it's a set, not a list. But it might. Yeah, no, it doesn't. Yeah. Because this is not a list. So there's no index here. There's nothing to apply it to. Which is using SuperPython. You said first is. You said if you said first dict equals user data 1. Would it print the same thing? No, it would print Bob, age, and height. Don't forget, sorry, user data in this example is an array. An array has indexes. So in this example now, it would print Bob. When I hover over the range function, you get all the information about the function. Did you install any additional packages? No, I did not. So the only thing you need to do to make sure this works, actually there's a couple things. Make sure that your Visual Studio Code has the Python extension installed. That helps it just know how to deal with Python generally. The only other thing you need to do is, if you look at my terminal, you want Visual Studio Code to be working in the directory of the Python project. That's how it can do that interpretation. Same if I hover over print. It's because my code directory is open to the right directory. It doesn't always work with SSH and things like that on VLab. Okay. Would print data 0 name work? Absolutely. That 100%. You've understood it. Who asked that? Ella. 100%. 100%. I hope it. Oops. Why does this work? Well, we need to break down what user data of 0 is. What is user data of 0? It's the dictionary. How do I look up a value in a dictionary? I use the key, in square brackets, just like I'm looking up an index in a list. The key is name. It's the string name. What's the value of the key name in the first element? It's Sally. So 100% Ella, you've understood it. You really did get it. If you get that, you really get the idea of how we look up elements in a dictionary, and even if that's within an array. Well done. How's all the Python stuff sitting with you guys? I know that the Git stuff is causing a bit of havoc, but how's the Python starting to sit with you? Okay, we've got another question. While you guys answer that question, okay, what is going on here? Oops. That's just, so user data dot key. I don't think that will work. Yeah, it has nothing called key. Is there a function called key? I'm not sure. I don't think there is either. Nope. Because there's keys. There's keys. There's the keys of the dictionary. Oh, I didn't print it. Let's see. Oh, this is, yeah, anyway. This is just the keys, but, oops. So you can get the name, age, and the height here. There's the dictionary keys, but there's no single key because you got it. Well, which key? Is it name, is it age, or is it height? Can we say for key, a comma user in user data? Let's have a look. I don't actually, let's have a look. For key val in user data, I think you might be able to print, let's print an F string with key val. Yeah, it can't. It doesn't, so it doesn't automatically unpack user data and destructure it to two key value pairs. I know why you thought it would. Like, it sort of sounds logical. Oh, sorry, user data. User data is the array. That's why. Yeah, user data is the array. So really it's like there's no key value for this element. This is just an element in the list. So yeah, you would need to unpack it exactly right. Cool. Yeah, Python is quite friendly and usable. play some, now that the lecture's formally over, play some Oscar's music to start to ease us into the real world and to play us off stage. But if you got some more questions, keep them coming. If the music's too loud, let me know. So in user data 0, is there a follow-up question coming, Richard? No? Oh, okay, sorry. Sorry. Oh, like this. Yeah, no. Can you specify Git push options? Which options are you referring to? Comments. But I do, sorry, Richard, I do understand why you would think you can do that. But you just have to be more explicit. So there are options for git push. So I just ran git push help, and these are some of the options at least. So you can start to go through some of these. There's a description of the options. This isn't very helpful, I understand. If you have a specific option that you had in mind, I mean, you can just see how complex and how much there is to Git if you get into the real depths of it. That's still going. How can we make a merge request in Visual Studio Code? You can't. You have to do it through GitLab or GitHub or whatever it is you're working with. So you push to a branch and then you go into the UI and you say, hey, I want to make a merge request between this branch that I just pushed to and this branch. And if you recently pushed to a branch, the UI will try and be helpful and surface that branch up for you. Let me show you an example of some pull requests. Remind me later, hopefully, just let me in. Some pull requests in a real project. Let me get a closed one, so one that's already been merged, and I'll try and find a good one. Let me find one by me, because I usually try and make good ones. Let's see, they're not all good though. They're probably not all ones by me. Let's see. Okay, here's one. What's this one look like? No, that's the wrong one. It's not a great one. I mean, here you can sort of see, so this is a pull request in GitHub, exactly like a merge request in GitLab. I pulled from this development branch, pulled from the header migration branch into development branch, and I described what I was doing in this branch. So in this pull request, I added a new and redesigned app header bar and some performance enhancements that I made. I went through a checklist, and you can see that this pull request or this merge request contained 41 separate commits that, all did a bunch of changes on on a branch. This branch was called header migration. And then when it came to someone reviewing those changes, you can click files changed. You can do all of this in GitLab and you can go through and you can see, okay, what did I change in this pull request? So this is where someone coming along who's reviewing this pull request can come and say, okay, yep, so we added some of these functions, that looks okay. We removed all of this old code, that's really good. Removing code is always a good thing, blah, 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 blah. And then you might have a conversation. Now in this case, there was no conversation on the pull request. It'd be good to find one where there was a conversation. That would be nice. To show you sort of what that looks like. No conversation there. I mean, this isn't a sort of typical project because I work mostly alone on one part of the project, but let's see. No, I'm not going to be able to find one. I'll try to find one for next week or something, but cool. Okay, well, that's 6 past. If there are any final questions, feel free to send them in. Do we need to commit on Visual Studio Code before a merge request? Yes, you need to commit, you need to push. Once it's pushed to the branch, then you can kick off the pull request. Would entry key val in user data work? No, that would not work. Something like this. Oops. Oh, that does work. What's going on here? So user data returns 3 things. Let's see here. Entry is name. Key is age. Val is... Oh, it's all 3 keys. That makes sense, actually. That makes sense because we're getting the keys. User data, when we loop over a dictionary, we get the keys. Because there happens to be exactly 3 keys in name, age, and height, we print out the keys. That makes sense, sorry. But it's, yeah, but if I had 4 here, then it would no longer work. Okay, well, it gets the first 3 out, I guess. And then if I printed a 4th, you know, it would be also height at the end. Whoops. If I get the syntax right. Oh, that didn't like that for some reason. Enter key val. Oh, okay, it does, okay. You can't have a duplicate key. That makes sense. All right, now if I try this, then we get all 4. So it's just, if we have the exact amount of keys in the dictionary, then we can destructure it. And they have to be unique. So good flag there. Okay, thank you all of you. I hope you enjoyed the lecture. I hope you're starting to learn a lot. It'll start to cement. How long will the project take? This project iteration, so there's 3 iterations to the project. I think this one's 4 weeks for this iteration, but the project goes for the entire length of the course. Yeah, that's right, Mikey. Cool. Thank you guys. I really had fun today. I hope you had fun. Try enjoy the dreary weather. Stay inside. Watch your lectures. Do some work. Have a good one. See everyone. I had a really good time today. Make sure you do the feedback. I'll go through and have a look at it after. Thank you guys. Thank you. Catch.